Okay, question 8, part B. It's about the boat and the river again. So I'm gonna use the same diagram. The diagram was this one. Give me a second. There we go. This is the diagram, and in this diagram what they say is if the width of the river is 80 meters, so we know that this is 80 meters, then how much time does the boat take to go from one shore to the other shore? So the point here is the reason why the boat goes from one shore to the other is because it has a velocity in this direction. If you think, this velocity will not affect at all the time that the boat takes to go from this to this. This velocity will take it up, but how long it takes to cross the river depends on how fast in this direction it is going. So to find the time that it takes to go from this point to that point, we just forget about this velocity, the 3, and we just use the horizontal velocity, which is 4. So I'm going to use the equation for velocity. Velocity equals this displacement over time, and I need to solve for the time. So the time will be distance or displacement over velocity. The displacement is the 80 meters that it has to cover, and the velocity is the horizontal velocity. It has 4 meters per second. In this way you can see that the time that it takes is 80 divided 4, 20, and the unit, because these meters cancel and the seconds go up, will be 20 seconds. So the time that it takes to go from this point to the other point is 20 seconds. I'm gonna go to part C straight away because it's very easy and it's related to this one. Part C is what it says is what distance downstream does the boat reach the opposite shore. So to understand that, look at the diagram here. If the river didn't have a velocity, right, if the water was not moving, then the boat will end up here, right, if the river doesn't move. But because the river moves and it takes the boat with it, this boat will not end up here. It will end up at a distance from this point. So what they want to know in this question is what is the value of this distance that the boat is taken up in the diagram by the river. So obviously how far the boat goes depends only on the velocity that the river has, not on the velocity of the boat. We just said that the velocity of the boat determines this time, but it doesn't determine anything in this direction. So I'm going to forget now about the 4 meters per second, and I'm going to work with 3 meters per second. So I'm working with the same equation, velocity equals displacement over time. But this time I'm going to solve for the displacement. So the displacement will be obviously equal to time times velocity. So I'm going to write like this, velocity times time. I'm just taking this t up. The displacement would be velocity times time. What velocity? The velocity of the river, 3 meters per second. And what time? Well, the time that it takes to go from one extreme to the other of the river. During this time, which is 20 seconds, the river will take the boat up in our diagram. So that is the time we use here, 20 seconds. So the displacement will be 3 times 20, which is 60 meters, because you know the seconds will cancel out. But the distance will be given at the end in meters. So to summarize here, what is happening to the boat is it travels to the right and it's taken up by the river. It takes 20 seconds to cover this 80 meters, and in those 20 seconds the river moves the boat a distance of 60 meters up in this diagram. So the two velocities are independent, and the first one is used to calculate the time, and the second one, the 3 meters, is used to calculate this distance. So the boat in the diagram will end up doing this, because it moves to the right, but it also moves up, right? And what we wanted to find is this distance, 60 meters. That's problem 8.